Assalamualaikum puan. My name is Haikal Syamil and I will be doing the introduction to our group discussion about the topic trigonometry. So we chose an air traffic controller as our situation or scenario to discuss about trigonometry. So this is our team. This is my group members. This is the content of our discussion, and I will be covering the first one, which is definition of trigonometry. So trigonometry is the branch of mathematics dealing with the relations of sides and angles of triangles and with the relevant functions of any angles. So for example, this is called a right angled triangle. As you can see, there is a 90-degree angle, and you can get sine A by dividing A and C, or the opposite and hypotenuse side. You can get cos A by dividing the adjacent and the hypotenuse side. You can get tan A by dividing opposite and the adjacent side, and so on and so on. So I will be passing on to my next group member.
Let's get on to my part, which is trigonometry in air traffic control. So, the air traffic control will send out a signal to the airplane. Then, the plane will receive said signal and send it back to the air traffic control. Thus giving us the distance between the airplane and the air traffic control. That gives us our hypotenuse. Meanwhile, we get the opposite side as 40,000 feet because the airplane already has a built-in meter to calculate the distance between it and the ground.
In this problem, we are working with a right angle triangle formed by the airplane, the control tower, and the ground, where the vertical side represent the height of the plane, opposite side equal to 50,000 feet. The slanted line is the hypotenuse, 100,000 feet, and the horizontal line along the ground is the adjacent side. To find the angle of descent, we use the trigonometric rule SOHCAHTOA, which reminds us that sine relates the opposite side to the hypotenuse, cosine relates to adjacent to the hypotenuse, and tangent relates the opposite to the adjacent. Since we are given the opposite side and the hypotenuse, we apply the sine ratio. Sine theta is equal opposite over hypotenuse. Substituting the values gives sine theta equal 40,000 k feet over 100,000 k feet equal to 0.4. To determine the angle, we use the inverse sine function. Theta equals inverse sine in bracket 0.4, which calculates the angle formed between the ground and the plane's descent path. This method shows how trigonometry can be applied to real-life contexts like aviation, where identifying the correct side of the triangle and choosing the right trigonometry ratio are key steps in solving for an unknown angle. In conclusion, trigonometry is important in air traffic control because it helps controllers accurately determine aircraft positions using angles and distance, calculate safe separation between planes, guide aircraft along correct bearings and glide paths, and ensures safe, smooth, and efficient navigation through three-dimensional airspace.